Well, good morning, and I'm going to give you a brief update on some herbicide resistance issues that I'm seeing happening. The vast majority of what I'm going to talk about today is actually going to be about ryegrass, and that's because of some of the things that are happening. So I'm going to start with the random resistance survey, the weed resistance survey that was conducted across Australia, across the Grange region of Australia in 2020. So this went from Western Australia all the way to central Queensland. And all of the blue dots on that map are where we collected ryegrass from. So there were over 1,400 of the paddocks that we visited had ryegrass in them. Ryegrass kind of peters out as you get up into northern New South Wales. I know it's present in Queensland now, but we didn't find very much in Queensland. In terms of resistance, and I showed this data last year, so I'm going to skip through it pretty quickly, but I just want to sort of reinforce a couple of points. So if we're looking at the Group 1 herbicides, particularly the FOPs and DENs, pretty much everywhere's got resistance, but there's more activity still in clethodim. So we still have some activity in clethodim, but we're starting to see, some quite large percentages of populations that have resistance. The Group 2 herbicides, AHRI and Idavix, it doesn't really matter. We've got resistance to both of them. It's pretty widespread. And the one that's starting to really shift is glyphosate. We're starting to see much higher levels of glyphosate resistance in these surveys than we've seen in the past. And we're not really picking up a lot of paraquat resistance. When we look at, so that's a post-emergent herbicide chemistry. So, what we've got left for ryegrass is our knockdowns and a bit of clethodim from time to time. And it's one of the things I want to talk about is to get at a more local level and talk about where these products are still working. The pre-emergent herbicide space looks a lot better. Triflurin resistance is significant in South Australia and Victoria, but not really high anywhere else. So it's present, but it's not at high levels. And we're picking up a smattering of resistance to Boxer Gold. If we were to put prosulfocarb in there, we would have probably a little bit more resistance to prosulfocarb compared to Boxer Gold. But all of the other herbicides, the survey's not picking up resistance. Now we know that we have resistance to Sakura, we have resistance to Overwatch, and we've got our first example of resistance to propizamide, real resistance to propizamide instead of that sort of weak stuff we used to have. But we're not seeing it in the survey, and that's because they're not common enough for us to pick up in that survey. So this is, those products are still going to be really useful for us going forward. So that's the national picture, but I want to focus down. I'm going to talk about just South Australia and Victoria, mostly because they're more local here, because there are some really interesting local trends of places where resistance is different. So this is the South Australian data. You can got the various regions in through there. You can match them up on the map. What we, looking at the den resistance, we've got a couple of areas here, the mallee and the upper part of the EP, so those drier areas where ryegrass is less of an issue, where we don't have as much resistance. But you don't have to go far from the upper EP to get down around Cummins, and everything has resistance to the FOPs and to axial. So there's some big differences just in geography. And again with clethodim, the upper southeast, the lower southeast, we're getting really high levels of clethodim resistance down in that area. And this reflects what the agronomists down there are telling me about clethodim. They basically say it's not working. Whereas everywhere else, it's lower than what we're seeing. I won't talk about the Group 2s because they're pretty bad everywhere. Paraquat resistance, it's in the southeast. That's where we're picking up, around Narracor. And for glyphosate, big numbers. The biggest numbers are in the upper north, which is probably a little bit of a reflection of the small sample set, but down here in the southeast again. So, and we've known that for a while, that glyphosate resistance is a much bigger problem down there than it is elsewhere. So there are some regional variations, and those regional variations are largely what farmers are doing in that area, what their common practices are. So where we have much more continuous cropping and much more weed burden and more focus on using multiple herbicides, we tend to get more resistance. Moving across to Victoria, again, the mallee, lower rainfall, less ryegrass, less resistance to axial. Everywhere else has got plenty. They've got less resistance to clethodim. When we start looking at this southern Victorian area here, now this was a late starter for cropping. They tended to be pasture and they've moved into continuous cropping since the late 1990s. They've really pushed that system to get high levels of resistance to these post-emergent herbicides and particularly to glyphosate. But this area up here, so this is, most of the cropping is actually down through here. It's a high rainfall area. Again, they've moved into continuous cropping and 46% of the paddocks there had glyphosate resistance. So we've got these little hot spots where glyphosate resistance is really bad. The pre-emergent herbicides, we do have some areas with trifluorine resistance. Now, across the state that was only about 38%, but we've got some areas, many areas, well over 50%, and I think that reflects what the agronomists would tell me. Out in Sam's area on the York Peninsula, I mean, trifluorine just doesn't get a go because more than half the paddocks have got resistance to it. What we're seeing is that there's a few of those areas, and really the mid-north is probably leading the way around resistance to boxer gold. Again, the mid-north was an earlier adopter of boxer gold when it first came out. That's where a lot of it was used. So, same pattern we're starting to see where these herbicides are being used a lot and for a long time. That's where we're starting to see resistance. I won't talk about the rest because there's nothing interesting there. Same sort of things we're seeing in Victoria to the pre-emergence. Interestingly, high resistance in the mallee, and that's partly because they've focused on using trifluoride for brome grass control. So they've actually been selecting ryegrass because they've been controlling brome, or been trying to control brome grass. The Wimmera, we'd expect a fair bit of trifluoride resistance. We'd expect less down in the south, partly because they're later starters. They didn't really get into trifluoride. They tended to go more for chemistry over here, and you can see that they're tending to break boxer gold pretty quickly. Part of that's actually driven more also by the use of prosulfocarb and the use of Avidex in their system. So it's not just boxer gold that's doing that. So I think the regional pattern of things that we're seeing indicates that, on a state basis we might say, oh, it's really bad, but there are places where, it's not such a problem, but there are other places where we actually have really significant problems in that local area. And I think that, if I talk to the agronomists, they would say, yep, we know we have problems with these chemistries in our area. So what I think that we could take away from this is that, we still have some opportunities, but those opportunities are getting smaller and smaller in terms of the chemistry we can use against ryegrass. So we're going to be so dependent now on that pre-emergent chemistry as being our main bit of chemistry. And we're going to have more and more other things in our system to make that work for ryegrass. So one of the things that does come up in when we do these surveys is always, the discussion point is the level of resistance that we find to clethodim. And everybody tells me, oh, we got much more clethodim resistance than you're pointing out. Some of that's because we're averaging across the regions, but some of it's because of how we do our testing compared to what farmers do in their paddocks. So one of the things we did this year was we took 129 samples out of that survey, so a mix of resistant and susceptible samples out of that survey. Grew them up to 2 growth stages, so that 3 to 4 leaf stage and then the 2 to 3 tiller stage. So they weren't widely different, but one was bigger than the other, and then sprayed them on the same day with 500 grams per hectare of clethodim. And this sort of thing, canola and sow thistle don't get controlled by clethodim, but this is the 3 to 4 leaf, and that's the 2 to 3 tiller. And you're starting to see that there's the odd plant that's surviving when they're bigger. And it turns out that it's more than that when you actually look at the data set. So if we just look at, in that set, where we do our resistance got to be greater than 20% survival, at the 3 to 4 leaf stage, that was 38% of the populations, and that shifted to 58% of the populations when we went to that 2 to 3 tiller stage. And statistical analysis of what happened, sample was significant, of course, because we had resistance and susceptible. Plant size turned out to be significant, and the interaction turned out to be significant. So as plants get bigger, if they're resistant, they get harder to control. So the average survival across all of those populations was 24%, 3 to 4 leaf stage, a bit over 32% for the 2 to 3 tiller stage. So that's the average, and effectively that means that they're a third more survival if you let the plants get bigger. So that's one of the things that's driving what's happening in farmers' paddocks, is most farmers are not spraying ryegrass with clethodim at the 2 to 3 or 3 to 4 leaf stage. And they're not even spraying them often at the 2 to 3 tiller stage. They're waiting for them to get bigger again. But there is another thing that's happening. And that other thing that happens is that as farmers leave it later and later to put clethodim out, so looking to try and get the product out just before canopy closure, it's getting colder. And we know clethodim doesn't like cold weather. So we've got this combination of large plant size, cold weather, and resistance. And that's why you look at our data and say, well, you know, you don't have as much clethodim resistance as we think should be there. It's because of these other factors that are coming into play, plant size and temperature. So one of the ways that we can get more activity out of our clethodim is to put it on earlier, when it's still warm and plants are smaller. It won't solve all the problems, because we still have, you know, a large chunk of our populations are still resistant at that stage, but we can control some of those populations that aren't resistant by putting that herbicide on earlier. Okay, last bit of topic on ryegrass. This is some data from Peter Botsalis' Plant Science Consulting Testing Service, what they've been testing this year. So they've identified 53 annual ryegrass samples that have come in that have paraquat resistance. And this has gone from hardly any, you know, the occasional one every year, to a large number in 2023. 48, so all but 5 of those, also had glyphosate resistance in them. And this is just one of those populations. 1.5 litres of glyphosate susceptible in the front there, 3 litres of glyphosate, got your resistant one in the back, 2 litres of paraquat. Glyphosate plus paraquat resistance. Where are they coming from? 18 of them from South Australia, 21 of them from Victoria, so it's South Australia and Victoria that are driving this. Less from New South Wales, a few from Western Australia and 1 from Tasmania. So everybody's having a hand, but South Australia and Victoria are driving the push around this. And this seems to be coming largely because what we've done is tended to drive our populations towards glyphosate resistance, and then we're using the double knock to manage that. And so on top of that glyphosate resistance, we've now got paraquat resistance. What can we do about it? Well, it's going to be challenging. This is not going to be an easy solution. Things we know won't work or won't do very much for us is adding a group 14 spike. Yeah, we'll get a little bit of extra activity sometimes, but that's actually not going to fix the problem. What some of the people are talking about now is doing a triple knock to try and get this ryegrass. So they're trying to introduce glyphosate into that knockdown space and use that as a tool. One of the things that we know about glyphosate is it's not brilliant on ryegrass, so you have to use reasonably high rates. And secondly, once it gets cold, it doesn't work on ryegrass pretty much at all. So, at that knockdown time, yes, we've got some opportunity around that. But we're getting into a position where we're going to have some real difficulty with that pre-sowing weed control. So I think that we need to pay much more attention to that now. We got caught out in when was it, 2020, when we had all that early rain and people just went out and sprayed glyphosate and came back 4 weeks later to find they had these great huge glyphosate-resistant weeds by the time they went to seeding. We don't want to be caught out by that again, so we need to make sure that we're doing other things. Things that we do know about glyphosate resistance is that if you're sowing close to the break or you're sowing on the calendar dry, sowing dry, it doesn't matter because you don't have to use glyphosate, so it's not going to be a problem. But if you're sowing close to the break and you get your crop in, these glyphosate-resistant weeds, they've been kicking around in our farming system for a long time, but people haven't really been noticing them. And that's because when we get good competition on them, we suppress them. It's only if we let them get big before the crop goes in. So crop competition is going to continue to be a tool for use for us, but we're going to have to find other things that are going to help us through managing this problem. Now, it's only 53 samples from 2023 at the moment, so it's only a small number of paddocks across the country. So I don't think we have to completely panic, but I think we need to be looking at what are we going to do when this happens on a farm that you're managing. Okay, the last really brief topic I want to talk about is phenoxy resistance, because phenoxy resistance is coming, and it's coming in a big way now. I did a survey for the clover seed growers down at Narracourt last year. We collected went into 30 paddocks, collected 30 samples of south thistle, 30 samples of ryegrass and 30 samples of capeweed, because that's pretty much all they had in all their clover circles. And when we tested the south thistle and the capeweed for resistance to phenoxies, and I've got bromoxynil in here for south thistle, 93% resistant to 2,4-DB, which is what they normally use, but also 93% resistance to MCPA. And just to make sure that nothing weird was going on, this is the broadacre rate of 2,4-D. Okay, it's not that different. These guys have a serious phenoxy resistance problem. In south thistle, developing in capeweed as a serious problem. This is 12 of the paddocks here. This one here, the only one of those 12 that was controlled by 2,4-DB. Turns out it wasn't controlled by MCPA. So it's still resistant to phenoxies. So if we bundle it all together, it gets to well into the 90% have resistance there. Now this is a very specific and particular farming system. And you would go, it's not going to affect us elsewhere. But this is the first farming system that picked up paraquat-resistant ryegrass in Australia. This is where the first paraquat-resistant ryegrass came from. Clover seed growers. So there's that, but there's also, for the group 4, we've got three new resistant weeds in 2023. Brassica tournefortii, I've got shepherd's purse, and this one, melons. Resistant to phenoxy herbicides. So it's not just particular weeds. I mean, south thistle's a particular problem with 2,4-D resistance. We're actually seeing an expansion, and a fairly significant expansion in the number of weeds we're getting with resistance to this mode of action. Okay, we had 2 new weeds last year, came in. We've got 3 new this year. It's building. It's going to be a big thing that we're going to have to deal with, because, you know, phenoxies are one of our most versatile and cheapest broadleaf herbicides. So there's going to be some real challenges for how we manage this problem going forward. For south thistle, fortunately, bromoxynil works. So, you know, we have a solution in some of our systems for that particular weed, but some of these other weeds, I'm not sure how we're going to control melons if we can't put Garlon on them. That's going to be interesting. So I'll finish on that bit of bad news, and I'm happy to take some questions. Thanks, Ken.
We've got a couple of questions from the online audience. First one, Chris, is with the increase in drift reduction practices and a general shift to larger spray droplets, nothing else.
Okay, so I think the question about larger spray droplets is about efficacy. Mm-hmm. So that if you're going for larger spray droplets, the idea is that you don't necessarily get the same level of efficacy, and if you've got low levels of efficacy, maybe you're going to push the population to resistance faster. I know that Jason Sabini's in the audience here, and you know, what was it, 15 years ago, Jason, Syngenta did a whole bunch of stuff around droplet size and most of the herbicide products that we were working with, and the ones where you can't get away or where you lose efficacy as you go to larger droplet size were products like diclofop, which we basically don't use anymore, and some of that group 14 chemistry, where you need really, really good coverage. Everything else, you could get away with coarse droplets so long as you got your water rate up. So yes, we can go there. We can get paraquat to work. We just got to use 100 litres of water per hectare.
Yeah, well, this is sort of on the same track. Are we getting more resistance due to less coverage and less chemical uptake in the plant?
I really think that the main driver of what we're getting for resistance is the focus on using the same bits of chemistry over and over and over again. You know, I used to talk about the lifetime of all of the number of uses of all of the pieces of modes of action that we had, and for some of those, say for the group 2 herbicides, we'd talk about 4 years of use for ryegrass. It didn't matter how you used them. You could use them once every 10 years. You still drive the population to resistance. For others, that was different. There were different things, but it's really the number of times that we're using individual herbicides. And you know, people have been continuous cropping in South Australia for getting on to 40 years now. It's plenty of time to have used up the vast majority of the chemistry that we've got. So usage is the big one, but also the fact for most of that time we've never done anything about the survivors. We've just let them set seed. And so what we're doing now is that we're doing a range of different things for some weeds, but not other weeds. You know, for south thistle, it's still, you know, we ding it with a phenoxy and the job's done. We're not doing anything else for south thistle. So we've got all this focus on ryegrass, but we don't have that same focus on some of these other weeds. And I think that's why some of these other weeds are starting to really build, because we're just focused on how we kill them with chemistry.
Chris, the info from Peter Botsalis' work, is that predominantly, how much of that is in paddock versus fence line or close to fence line glyphosate paraquat resistance. And I suppose the second question then also, knowing there's probably Bayer people in the crowd, but with Allion potentially available next year with a residual option is going to be give farmers a fair bit of excitement. What would you suggest if things get through? Or is there a program that you think of chemistry that farmers should use if stuff does come through?
Okay, so that's a really complicated question, Sam. We know from past work we've done that glyphosate used on fence lines, selected for glyphosate resistant, and then that moved into the paddock because there was no competition on fence lines. And selection of using paraquat on fence lines is going to do the same thing. Okay, we'll end up in the same boat. I haven't checked with Peter about how many of those were fence lines and how many of those were in paddock, but the conversation indicated that at least a chunk of them were in paddock. So I don't actually have the actual numbers, but they were samples sent in for testing. Going forward, fence lines are going to continue to be a troublesome space for us if we're using the same chemistry on fence lines as we're using in crop. And I know that when I was doing all that work on fence lines, at one point I sat down and started looking at bits of chemistry that we might be able to use that people weren't using in crop, and that's where Uragan came from, that thinking. So I think one of the advantages going forward is I think Allion will offer us a different way of doing this, because Allion's going to be a mode of action that we're not actually going to use in crop. Okay, the only place it's going to get used is in turf and on fence lines. So that offers a real opportunity, because then it doesn't matter if we get resistance on the fence line so bad, because if it gets into the crop, we're doing other things. It'll be bad for fence lines, but not for the cropping space. So using Allion, I think the big thing is that if we're going to head down that path, you're going to have to change farmer behaviour, because you can't go and put that out when you've got nothing to do in August, because it doesn't kill existing vegetation. So this needs to go out on bare ground to work. So that's going to be one of the things that we'll have to change. And I think we'll find that there'll be some challenges where it goes out on fence lines to get driven over, for example. We'll probably see some breaks where weeds will come through that. So we might have to rethink how we're operating, if we're using Allion, how we're operating on those fence lines, what are we doing on those fence lines, and how often we're trafficking on them. So my guess is that we'll have some learning experiences when it first come out. People will do things and they'll go, it hasn't worked. Well, it hasn't worked because they haven't done it right. And it'll be like some other chemistry we have. We've got to get it right. So you've got to go on bare ground, and you've got to leave it alone as much as you possibly can. I think are the two secrets to making it work. If you are going to, we've done that. We've gone and put it out mixed with other things in August. It doesn't do anything then, but it actually keeps the fence line clean through the next winter. Starts to break after about 10 to 12 months, roughly. So, you do have an opportunity of, if you're out in that August time of putting it out, just don't expect anything to happen that year. It'll all be next year's control. If we get survivors there, I think that, it's probably the solution is that how late are they coming? So if they start coming early, then we probably need to do something else to control them. And that could just be a little bit of manual removal or whatever is needed, because you probably won't, unless you have a really bad experience, you probably won't end up with a whole fence line full of weeds. It'll be a weed there, a weed here, or maybe a few weeds just on the wheel tracks will come up.
Okay, Chris, can we... Thank you very much. That's been great, and thank you for all your questions. Let's give Chris a hand.